My name is Michael. I am the creator of SupaNuxt SaaS. I just want to walk you through the technical architecture today. So here's the overview. This is available in the README. Let's walk through it. Firstly, the database. I've chosen to use Supabase Postgres. So this is a Postgres instance hosted in Supabase. It is your permanent domain state. That's where all of your data is, your business data. The schema is managed by Prisma, so all of the updates to the schema are managed by the Prisma library. The next thing to talk about is the data access layer. So that is also Prisma. That is in the Prisma folder. It handles all of the interaction with the database, so the connection, queries, transactions. It also produces basic schema types. So a type basically where a table equals a type. For example, account and member. I chose not to use the Supabase API to access the database. That was just a choice to avoid lock-in. So the data access layer knows how to talk to the database. The next part of the architecture is the service layer. It contains business logic and features. It's functions to retrieve and alter the business model, relationships between the objects, e.g. A new user needs a default account. So that information, that knowledge is in the service layer, not in any other place. So it's a sort of a central place for all of your business logic. It also produces service types. So these are more complex types. These are usually aggregated and composed from the basic types that come from Prisma. So, for example, account with members is one of those service types. All of the service code is in lib services. The application doesn't hit the service layer directly. All of the access to the service layer is done through a remote procedure call layer, which is TRPC. This is really cool. This is procedures that are callable on the client or the server. So these are procedures callable from TypeScript. You call them exactly the same on the client and server. So the syntax, procedure, and types are all identical, server and client. It's organized into routes, for example, notes and the account route. And this is where we apply access. This is where I apply access control. So you can have public procedures, member procedures, admin procedures, owner procedures, and procedures that can only be executed if you have a special feature in your account. So all of that is controlled at this RPC layer. So let's talk about the sort of page rendering. So I'm obviously using Nuxt for this architecture. Nuxt gives you a thing called universal rendering, which is pretty cool. It means that your pages can either be rendered on the server, usually for an initial page load, or they can be rendered on the client. Usually, if you browse to a page from within the app, it'll render that page on the client. The beauty of the architecture is because the code on those pages accesses the data through that RPC layer, through TRPC, and because TRPC presents the same interface if you're on the client and the server, then the code on those pages doesn't need to know whether it's being called on the client or the server. So that's really quite cool. Universal rendering is really cool. It gives you search engine optimization and smooth page transitions. So it's really the best of both worlds. Nuxt, the framework, decides whether to render on the server or the client. I usually use universal rendering for two things: for public-facing pages, so things like the index page and the pricing page, and also any published content generated by users. For example, if you allow users to create notes, which is part of the demo app, and you want them to be able to publish those notes publicly, then that published notes page would be universally rendered. Also things like if you could imagine doing a blog, the blog articles would be similarly rendered. So that gives you most public-facing pages, published pages, but it's not actually your software. So your software is usually more dynamic, involves complex state transitions. You're allowing the user to modify the state, to mutate the state. To do that, you need to go an additional level in the architecture. So You need a global state store to manage all of that state on the client when you're doing complex operations on the client. So I'm using a global state store, which is Pinia, which is the recommended state store for the Vue and for Nuxt. This central store of state usually includes a partial mirror of the domain state, so it might involve a list of notes or whatever that is. Usually you use this for state that needs to be shared across multiple components and pages. But in addition to the state that comes from the database, it can contain state that only makes sense on the user interface, like the filter settings and the filtered subsets of items that the user has chosen, the sort order settings that the user has selected, etc. So what is the currently active account? That's a user preference, and metadata to assist with CRUD operations, like which items are selected for multi-actions. So that global state store is accessed from client rendered pages. So these pages are usually rendered only on the client. So you either use the page.client.view name, or you set SSR to false. The client render pages work exactly the same, but they pull their data, instead of pulling it from the RPC calls, they pull it from the state store with a store to refs call. All of the store information is in the stores folder, and all of the client rendered pages, an example of a client rendered page is the dashboard view. All of those things render HTML. So client only rendering, again, this is for complex user interfaces where you've got user actions that alter data, usually private, not visible to search engine crawlers. This is really the software in your SaaS, the S in your SaaS. Things like notes authoring, accounts management, group management, or whatever else you dream up as part of your SaaS software. So that's all I'm going to go over today. That's the architecture of SupaNuxt SaaS. I hope you find that useful. Thanks very much.